All right, you guys. So today we are back. So today we're going to be chatting about how we are going to transform our inventory tracker to something that we could possibly use for an AI model. So this is an example of what would be a best case scenario for data transformation. So let's say that you're wanting to add a chatbot or enhance your search with an AI program and you want to see what works for you. So this is an example of what is added on. So if we look, we can see that we actually added on something called a style, which is basically an indication of what it calls a vibe, or at least that's what it stated, like a vibe, like if something is boho, streetwear, etc. And then that is also correlating with the era that it comes in. Now we did include the period or era. We did not have these attributes. And a lot of times you don't want to put these attributes on because it narrowed down the results for someone who's looking for something more general. So maybe you want to do it separately. I'm not sure. Where you have a regular search and an AI search, I'm not sure. It also depends on how the model and the AI search is integrated into the website. So what makes it different? Like what makes this so different from just a regular search? Well, to be quite honest with you, AI isn't actually processing information the way a human would process information. It is actually looking for attributes and it builds up a sort of digital tag for that particular attribute. So one dimension might be it has legs if this was a chair. The other dimension is made of wood, and the other one is like it's attention for setting. So it's not a decorative chair. It's not like there's actually a vintage chair just for childbirth. I know it's not technically for setting. It leans forward. It looks really kind of weird. I don't know how you would get that into dimensions, right? Now this is what the AI put out. It says vectorization turns math into high dimensional space. Basically, you can actually visually see what it looks like to it as far as position goes in a map, and I'll show you that later. But it's saying that the challenge is that humans can't visualize 100 dimensions and we can only see in 3. Well, we don't need 100 dimensions to know the difference between chairs. So basically it's saying that it can reduce a computerized image that it created for itself back to something that we can read. But ultimately, we don't need to have 100 dimensions to see the difference between a chair. Just like I don't need 100 dimensions to see the difference between a stay and a corset, a historical stay and a corset. I can see it visually. I don't need to put it to the computer and a bunch of data points. But you can use this for something that's within the computer. So the next thing that we're going to look at is we're going to look at something that is a representation of positioning when someone is searching for something. Let's say that they want to search for a funky 70s outfit for a party. Let's say that you have an AI chatbot or a search that allows people to do that. You can see plotted on the line against the other inventory where it lies in similarity. So I suggested, hey, show me the positioning of a 1990s black dress versus 1970s outfit. So they lie positionally fairly close, but there's some data points in between. These are the similarity scores. The closer to 1 for these, the better. That means your results are actually good. And I can show you what that looks like. So I actually did a test in code and Google Colab, just a very small test with some simulated data. And basically it recommended style attributes, which is like boho, minimalism, grunge, the things that we actually added in. So I ran it without it because I just wanted to see if maybe the store owner doesn't want to add that in because of the limitations. Maybe not limitations computational wise, but maybe just limitations on the garment and how people see it. It actually got a little bit of a better score than the ones with the style. But then I ran it again the other way and the scores change again. So I guess it kind of depends on how you design it. It also depends on how well the pre-trained models are, because these are pre-trained models. If you have something like very particular, like historical, or you want things to be done in a particular way, I always recommend, businesses look into something that's a little bit more controllable. Now, how much control they have over it is going to be a little different, because it's not only security that you have to think about, but also financial. Pre-trained models are also, you have to think about financial, and you also have to think about security. So, pre-trained models, it has to go somewhere, or some information or attributes of whatever this is going somewhere. So these are very important things to consider. So having a really good AI consultant or a business flow person like myself can help you, versus a person that just knows how to consult on a product. Knowing the math and limitations of what you actually can do, and some things that you and your developer can hypothesize on and create theories on is another. Preparing your data is step one, and then talking to someone that's actually creating the LLM is another. Because the data has to be there for them to use, otherwise you can't use it effectively. So you want the best case scenario, and that's pretty much what I asked. Is that what is the best case scenario for the data, and this is what it put out. This has to be confirmed though with a person that's actually going in and developing your model. Just like I did a very small test. I came to my own conclusions. I want you to come to your own conclusion. So just going back to this, so this is what it sees. There's no vision, there's no information regarding the computer seeing something. Your information is probably stored somewhere, or it's referenced to something somewhere, but like having it actually understand visually, it's not going to be the same. So that's why some things that maybe is generative is slightly off, because it doesn't see it. It's just seeing positioning. So let's zoom in on this a little bit. So the perfect match, if we put in a funky 1970s outfit for a party, is 0. So we are wanting absolute 0, which is 90 degrees, which is aligned with the math, which is called cosine similarity. So you can look that up on YouTube. You can look that up maybe in some of the general AI models to break that down for you. But basically, that's all they're doing, is looking at various different data points. So our query is here, or our search term is here. And then our top matches lie somewhere close to where it is. So the closer it is to 0, the better. And 90 degrees is where 0 is. So it should be here. But instead, we don't have a perfect match, so we have to look to see which degrees is closer. So the degrees is closer is going to be this one here, and that one is closer to 0, of course. So it's saying that the dress is closer than trousers. Okay? I hope that makes sense. I had to think about a lot, like, how am I going to actually tell people? Like, how do I actually explain to people the math behind this? And I think visually you can kind of understand it, and then you can go and plug these keywords in, so you can then understand more of like how to process the math, and you can ask it to process math. Like, how do you calculate this? So that's basically what it is. It just gets this and stores it into a database. You can have a vector database. I don't know if you guys have heard of that before, where it stores this information about your data, and then you can pull it through and interact with models. I will say also is that these, like PCA and this model is a map. It's just another model compressing the information so you can see it in 2D. It is this one, these are the raw scores. So that is what's happening in the back end. And to visually see it, we use another computational mathematical model to then compress the information to something that's visual. So that goes right back to what we started from, which is, it's getting dimensions that it's created within its own computer system, and then plotting it, replotting it to you to see similar to what it sees, but in 2D. All right, so hopefully that helps out a lot. I will be pointing a lot to this video for people who don't quite understand what's going on under the hood and maybe kind of confused about what is happening and actually as it works and why it doesn't work continuously, and what steps they need to take to actually start implementing and trying out and experimenting with these types of models. All right, so if you guys have any questions, let me know. I'll leave a link where you can book me for a session. Until then, I'll see you guys next time.